Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. My name is Julie Tomei, and I am joined by Dr. Elena Hyde. Hi, Elena.
Hello, hello. It's always fun to be out on York Universe.
Absolutely. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, that being Tuesday morning at 2 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. You can head over to www.yorku.ca/science/observatory and follow the links to OPV, that is online public viewing, and join in the chat. If you have any questions or comments about past shows or any suggestions for future topics, please send us an email at observe@yorku.ca. Of course, you can contact us over the socials. We have a slew of different handles depending on which network you're on. So on Twitter/X, our handle is at York Observatory. On Instagram, at the handle York U Observatory, and on Facebook at Allan I Carswell OBS. Our programs are free, but if you would like to make a donation, we certainly won't say no. Head over to our website, yorku.ca/science/observatory, and click on the buttons for donations. We'll be monitoring the chat room for questions, maybe post some content there. The current weather is clear for the first time, and it feels like forever. I saw some stars last night. It was lovely.
Amazing. Yeah, we're
There was
finally getting research observing as well.
nice. There was this bright orb in the sky today. I think it's the sun.
Yeah, it actually got properly warm. I think it's a strange feeling in Toronto.
Yes, I think it is February, right? We're always good for a couple of weeks in February for some nice clear skies. So uh, needed, so needed.
Yes, indeed. And we're obviously looking forward to doing lots and lots of catch up on our research observing. It is just a smidge too hazy tonight to do the online public viewing fully online. So you will be seeing some lovely stock images coming through over onto YouTube tonight. But rest assured, we have oodles and oodles of research data on SX Phoenicius variable stars happening finally, thanks to some very intrepid observers who stayed up quite late, getting lots and lots of data. So great work by the observatory crew.
Very nice. How long has that project been going on?
You're gonna have to forgive me. Addition is not my strong suit. So I believe since the 95, if I'm going back through the data archives correctly.
Wow.
But it's over well over 20 years
Yeah, absolutely.
of SX Phoenicius variable star data in various conditions, because of course over the years it has been recorded with different telescopes, and since 2019 we've actually been able to use the 1 meter as well, which has really cleaned up and improved the data quality, which is always nice.
Nice.
But yeah, I will just call out, actually, since at the end of your intro, you did mention the observatory does have donations. And I would just like to take a moment at the start of our broadcast to remind our listeners that it is actually tax season in Toronto and in Canada. And if you're looking for a tax deductible donation, I can highly recommend it. So I have it on good authority that if you do click the donate button, it may or may not be beneficial to your taxes, depending on what your your advisor says. Um, So in any case, I feel I just should add that during this perhaps timely moment as everyone starts to wonder about when they're going to get their tax forms in.
Love it. Definitely a worthwhile cause. I may be biased, but you know. Um, okay, so let's jump into our space and astronomy history. Do you want to start us off, Alina?
Yes, absolutely. Let's get out into space and do some space and astronomy this week, but in history. So you know we love the early space era in this on this show, and in 1959 things were really kicking up. You had all kinds of great things happening in the northern hemisphere, and you had some pretty fun stuff in the form of the Pioneer program, which was an American, an American sort of program run by NASA, obviously. And on this day, sort of actually yesterday, February 4th, 1959, the United States Pioneer 4 spacecraft was trying to go and photograph the moon. So the plan was that it was going to fly by and actually photograph the moon. Unfortunately, it didn't quite work out exactly how they how they had planned it. The flyby did happen, but they had a little bit of problems with the photo. The second stage rockets for the Pioneer 4 spacecraft actually failed to cut off in time. So that means they kept on burning or accelerating a little bit too far, and they went right past the moon, too far away for the imaging scanner to function. So they actually got to such a distance that they couldn't take a picture anymore. So
Oh,
Pioneer 4 tried. It became the first American craft to leave Earth orbit, and they were able to collect some useful data on radiation in space. But yes, it is known as the near miss of 1959. And if that all sounds a little bit odd and familiar, February 4th, 1959 was a spectacularly unlucky time in North American history because actually this was the day after the music died. And you might have heard the lyric, "The Day the Music Died." On February 3rd, 1959, this was the famous aircraft accident where the rock and roll musicians Buddy Holly, Richie Valens, and the Big Bopper had actually just been killed in a plane crash. So a little bit of, I don't know, it was a doubly unlucky point in history because, of course, you had two unrelated accidents, but happening within a day of each other. The Pioneer 4 spacecraft, of course, obviously was uncrewed, so that's much better. And it did successfully go out and do radiation measurements. It was, as I say, part of this early exploration period, 1959. They had the liftoff from Cape Canaveral, run by NASA. So your older style computers would have been involved, and you can just sort of kind of almost picture this sort of early attempt in sort of we're going to go take a picture of the moon. And the Pioneer program, I should mention, it was two series of lunar and planetary space probes, and they actually had that from 1958 all the way through to 1960. The Pioneer programs were from the United States, and they were trying to send spacecraft to the moon. And they did send one spacecraft to investigate the interplanetary space between the orbits of Earth and Venus. And then the second program for Pioneer was 1965 to 1992, which was the one that sent spacecraft to measure interplanetary space weather, explore Jupiter and Saturn. And they had the outer planet probes, Pioneer 10 and 11, which were the first two of five artificial objects to achieve escape velocity that will allow them to eventually leave the solar system. And so those are the ones that have the golden plaque of information just in case extraterrestrials find them someday. But Pioneer 4 was not that one. um, so don't get them confused. And it's actually got a really cool design. I will say that this little spacecraft sort of flying by and doing too good of a job at accelerating. It's kind of like a dart tip. It's got a cone-shaped probe, and it almost looks kind of like a dart, so you can kind of imagine it just zipping right past, and then not being able to, of course, get the pictures that they wanted it to get. Um, and if you're interested in some of the data that came out of it, they do still have the data available for download from the NASA archive. So a little bit of fun and a little bit of unluckiness in a very strange and unlucky time of history.
That is a really neat design.
It is. It does. I mean, it's almost like a dart or maybe a sharpened pencil tip.
Yeah.
I haven't seen a lot of others that use that. And we're used to some cool designs because in this time people were still, experimenting with things, and you had some very fun spherical designs. But this is the one that really looks, yeah, like a really pointy top or pencil tip or something, cone shaped is
Yeah.
the official description.
It definitely looks mid-century.
Yes, and it's say it did have some lead shielding around it to sort of help it improve its reliability and signal strength. But unfortunately, it was not able to get any kind of image of the moon when it went out. So we had to wait a little bit longer for our moon pictures.
We got there. All right. Speaking of the moon, we're going to move forward a few years to February 10th, 1961. And here we have a voice message sent via the moon. So this message was sent from Washington, D.C. to Woomera, Australia. Did I pronounce that right?
Yeah,
Okay.
Woomera. That's absolutely that's absolutely how I've always said it. So
It's a funny looking word. Anyways, Woomera, Australia. And the signal was bounced off of the moon in order to get it from one side of the Earth to the other. Um, and during this call, it was NASA Deputy Administrator Hugh L. Dryden speaking by phone to Goldstone, to the facility at Goldstone, California, and then the signal was sent there to Australia. It was part of the official opening ceremony for the facility at Woomera, and the facility is called Island Lagoon Tracking Station, or Deep Space Station 41. And it was the first deep space station to be established outside of the United States. It is located next to the Island Lagoon Salt Lake in the desert, and it's 25 kilometers south of Woomera, South Australia. The area was chosen because the Australian government was already working with the government of the United Kingdom on rocket and satellite research at the nearby Woomera rocket range. So I guess they're already working there, might as well keep all the space stuff together. And it began as a trailer installation in 1957. By the 1960s, consisted of permanent buildings and was a major unit in the network. So it served during Project Mercury as station number 9 in NASA's manned spaceflight network. The tracking stations were needed there needed to be at least 3 at equidistant points on the Earth's surface in order to continuously track spacecraft. So the first location was Goldstone. That was established in 1958. And then Woomera was established in 61 and, well, established in 58, but or actually, well, the grand opening, sorry, was in 61. And then the third one, because well, I list two of the three and not include the third one for completeness, was okay. This is a big long word, and I'm going to massacre the pronunciation, but Hartbeespoke Radio Astronomy Observatory.
You're so close. It's hard to be stuck.
Okay, Hartbeespoke. Better?
Assuming that it was Dutch, but I
I'm
think it.
assuming I'm assuming Dutch because it's in South Africa. It's 50 kilometers west of Johannesburg, or maybe it's Afrikaans, which is Dutch
Similar, yeah.
adjacent.
Yeah.
And that was established in 61. So we had 59, 60, or 58, 60, 61, those three major stations opened. And it was operated by the Australian Department of Supply and supported deep space missions until December 22nd, 1972.
Yeah, I love this. I love this article, not just because it features Australia, but it's actually they did so much with their deep space network, and the deep space network in Australia is still active, but more so for Canberra now than
Mhm.
Woomera. But it is a bit funny because the area is actually extremely small, and it is uh, just a few hundred people in terms of population. But for astronomy, it's actually done some pretty amazing things, even up through current day, because it's got an amazing facility for radio astronomy. Although it's almost maybe the opposite of Canada. Like if you were to go to a complete place that was as opposite to Canada as you could find, this would be pretty close because their mean daily temperature right now in February is 33.8 Celsius or 92.8 Fahrenheit. It is summer, but in the wintertime for them, it only gets down to about 17 degrees Celsius or 62 degrees Fahrenheit. That's pretty much as cold as it gets, and the rainfall is also not particularly high. So it's a little bit the opposite climate, and I just have to say that you know the fact that they've done so much over such a long period of time, despite being such a small area, is kind of awesome. The Woomera was also where they actually did the reentry for the Hayubasa. It was the capsule that came back.
Oh, cool.
And the return capsule for Hayubasa, which was 2010, so not that long ago.
Mhm.
That's recent history. They actually had the return capsule land in near Woomera, and they found both the capsule and both pieces of the heat shield that had come off. And um, yeah, it's kind of interesting an interesting astronomy area, despite it being low density and kind of a extreme environment.
Have you been there?
I have been close. I didn't actually get to stop by Woomera, but I was nearby-ish. Um, I mean it's I was in Adelaide, so it's not that close, I suppose, but only a few hundred kilometers away. So in terms of landing circles, I was basically right there. But yeah, it's about 400 some kilometers or 270 miles north of Adelaide, which is a major city um, for South Australia.
Awesome.
Anyways, little Australian trivia to go with your astronomy day. And yeah, they did actually recover Hayubasa in 2010. So um,
Amazing. I'm always up for some Australian astronomy
Australian astronomy trivia. Yeah.
Yes.
The outback is a great place for finding things, actually, because it does have a lot of sort of exposed, open surfaces.
Yes.
All right. So I suppose, anyways, that's my
Yes.
tangent. But this one's pretty cool because, of course, in the 60s they were really getting out with their deep space network, which we're still relying on today to keep track of our most remote items.
Hmm. All right. Let's move on to our third item.
All right, so away from crashing in the desert of Australia to um, something a little bit different. So I'm going to go on a NASA mission with everyone. So STS 41B. There's only two S's, not three. This was NASA's 10th space mission. STS 41B, just to make sure that I'm saying it correctly. So this mission was on February 11th, 1984. So we're, zipping a few years ahead. We've gone from the 60s to the 80s now. This STS 41B mission was when Challenger became the first shuttle to actually land at the Kennedy Space Center for NASA. So this was the first shuttle landing at Kennedy, and this brought the STS 41B mission to a close, a successful close. And this was, of course, a nice, proof of concept, I suppose. And the mission had a lot of other firsts. The STS 41B. So just to make sure I've got it right, this was an 8-day mission. And they had several astronauts up there. They also had managed to do the first untethered spacewalks made by two of the astronauts. And they were very excited for it, getting their first landing on the Kennedy Space Center in the 80s here. It actually made enough of an impression in 1984 that they were escorted by military aircraft from the United States Air Force. So they had a T-38 escort chase plane. And if you go look at pictures of the landing, a lot of them will feature the shuttle and its chase planes sort of coming into the Kennedy Space Center, which I thought was kind of a fun little thing you don't hear about often. I was like, oh, and that's kind of nice. And of course, this was NASA's 10th space shuttle mission, so it's not the first one. They'd done several before it, and this was the fourth flight for the space shuttle Challenger. And basically, what they were doing for those 8 days was going into space, deploying two communications satellites, and because they have a logical numbering system, this was they sort of try to count them up, but they did a funny thing with this. So STS 9 was the ninth NASA space shuttle mission. STS 41B was the 10th. So what happened between STS 9 and STS 10? Well, STS 10 was canceled due to payload delays. And then the next flight, which was originally designated STS 11, actually got subjected to a whole new numbering system. So they had a cancellation, and I don't know what it confused where, but they went from going, 6, 7, 8, 9, and then they couldn't get to 10, so they went to 41B. So I thought that was a little bit of fun trivia. Of course, they had 5 astronauts, so they had Commander Vance Brand, pilot Robert Gibson, mission specialist Bruce McCandless the second, and a lot of these people had been in space before, so especially the commander Vance Brand, this was his third flight, but it was the only flight for mission specialist 3, Ronald McNair, who was a pretty notable a pretty notable NASA astronaut. He unfortunately died at the age of 35 while on Space Shuttle Challenger in STS 51L. So he did not, unfortunately, did not survive his next one. But this STS 41B was fine. Oh, everything went fine, and he did come back from this one. But yes, as I mentioned, Challenger had many, successful flights and returns to Earth before it got into trouble. But this is the Challenger you may have heard about. It did have its last flight with the 1986 when it disintegrated 73 seconds after liftoff, which was the Challenger disaster as it was called. So before then, it had several flights, and they do say that maybe we could have done more with maintenance. But back in 1984, it was only the actual 10th mission that they were doing, and at least that one they did all get to enjoy. The the original mission in the 1984 8-day walk, they had a bunch of different things. So like most missions of the time, they tried to multitask as much as possible. I mentioned that they deployed satellites. They also began a tradition of playing music to the astronauts. So this was actually the mission that started wake up calls. So the oddly named STS 41B that was had its name changed somewhat spontaneously, February 11th, 1984. This is where they had the first used music to wake up the astronauts. And what they do, which is I think is kind of cool, is they actually let the tracks get chosen by astronauts' families or friends, and they have the artists and the songs recorded for some of them. And actually, you can look up what songs were played on what day. There was a jazz song played on day 3. There was an armed force medley played on day 5. Um, and some of them are actually not recorded, and some of the artists aren't listed. So it's kind of a fun thing to go back and look at, what they used to play to wake up the astronauts. And it's like, I wonder who sent that song in for for that person. And some of them are easy to find. So people would send songs from their universities, for example. There was one that was Southern Mississippi to the Top, which was played for the University of Southern Mississippi. So it would only make sense for someone who had gone to that university. So it's a little bit of fun stuff and a lot of work, obviously. And they came back 8 days later, first shuttle landing at Kennedy. And of course, Challenger, would go on for several more missions, but it was the Challenger disaster in 1986 that really, I think, put quite a stop to the momentum that we were seeing in space travel up to then.
Yeah. Where were they landing before Kennedy?
Um,
Like, were they landing in
let's
California?
have the Kennedy Space Center landings. That's a good question. Where did they land? Um, hmm.
No, Edwards Air
Because they
Force
launched
Base.
they launched at Kennedy.
Yeah.
They
I,
launched at Kennedy
I
for
s-
for most of them.
yeah. Yeah, in California at Edwards.
Yeah, because they do have several, and I remember we've actually talked about this on this show before. There are some cool landing and launch sites that you wouldn't necessarily have thought of.
Well, I find it interesting, like that the original, like I know, like eventually they all landed at Kennedy, and then Edwards was the backup. And I'd always
Yeah.
assumed that was the original configuration
Well,
because
Edwards
then
Edwards
you have
was
to ship the
definitely
thing
used
across the
for,
country.
yeah, like drive it on the drive it on the highway across country. I guess because I mean I know Edwards was listed as the landing site for quite a few of the previous missions, if not all of them.
Yeah. Interesting.
Actually I'm not quite sure. I wouldn't swear that it was all of them, but I can't think of where else they would have gone to other than Edwards.
One way
But yeah,
submission.
driving the shuttle across the country. Did they do that on the highways or did they take it on a boat? Trivia for our listeners.
Mm.
Answer in the answer. Tell us if you know the answer, um, or just look it up and have fun. So
Cool.
speaking of spaceships and STS missions,
Yes. Well, we're going to move forward uh, a decade and a bit. Uh, but same day, February 11th, 1997, and we have the launch of STS 82. This was the 22nd flight of Discovery and the 82nd space shuttle mission. So they somehow got back to numbering them for the number of the mission that it was, more or less. This was the second servicing mission to the Hubble Space Telescope, or HST. And the crew repaired and upgraded scientific instruments on board the telescope. They did a total of 5 EVAs over as many days for a total of 33 hours and 11 minutes of EVA time. The fifth EVA was an unscheduled EVA, and it was to repair the insulation on the telescope on the side of HST that was facing the sun and in the direction of travel. There was some damage to the insulation that the astronauts noticed during their scheduled EVAs. And so they did a fifth unscheduled EVA to add some insulation to protect the telescope. So they removed 2 older instruments and installed 2 new astronomy instruments. So the Goddard High Resolution Spectrograph was replaced by the Space Telescope Imaging Spectrograph, or the STIS. And the Faint Object Spectrograph was exchanged for the Near Infrared Camera and Multi Object Spectrometer, or NICMOS, or maybe they pronounced that Nick Moss. I'm not sure.
I think it is Nick Moss actually.
Seems to make sense, or else it's just a mouthful to say all those letters. And they replaced other existing hardware with upgrades and spares. Hubble received a refurbished, fine guidance sensor and an optical device that's used to provide pointing information for the telescope and as a scientific instrument for atmospheric science. And a solid state recorder replaced one of HST's reel-to-reel tape recorders. And that just tickles me that HST had a reel-to-reel tape recorder. One of Hubble's 4 reaction wheel assemblies, which is part of the telescope's pointing control subsystem, was replaced with a refurbished spare. And study of the returned mechanism provided a rare opportunity to study the equipment that had undergone long-term service, that being 7 years in space. This was particularly looking at the effects of the vacuum on lubricants, which were found to be in, quote, excellent condition. The Hubble Space Telescope was deployed in April of 1990 and was designed to undergo periodic servicing and upgrading over its projected 15-year lifespan. The first servicing had been performed in December 93. And then at the end of the mission, they reboosted the telescope's orbit by 8 nautical miles. And then the next servicing missions were STS 103 in 99 and STS 109 in 2002. as we know, it has long outlived its 15-year lifespan, and there are no plans for more refurbishing because there are no space shuttles, but it's still going.
Yeah, it's pretty amazing. It has like so many other missions that have succeeded, it has succeeded absolutely fantastically and way past its lifetime. I mean, despite the obvious teething pains of its mirrors not initially being quite what they should, it was so good that it was worth upgrading, and it is, worth noting that in this day and age of the JWST, the Hubble Space Telescope is still the optical light imager that is the best. It's just got the best chance of finding those incredibly dim galaxies and other things that you might want to see. So the question of how long they're going to be able to keep it going, are they really going to let it just crash back to Earth, or somehow will it get a last minute reprieve and stay up there for another, I don't know, 20, 30 years?
We must squeeze every last bit of science out of that telescope.
Well, and it is still an incredible instrument.
Absolutely.
And the fact that it's in space does mean that you avoid so many of the problems that we have here on Earth with light getting through the atmosphere. Um, Of course, I will just point out as well, if you are listening to this show, there's a chance that you might be a stargazer, and the Hubble and the Hubble and the ISS are both things that you can track from the sky. I think the one that I've seen used most often is the Sky and Telescope satellite tracker. But even just Stellarium will show you what satellites are up. Although if you want to actually see Hubble, you do need the tracker because it only appears across in certain times and places. It is very fun though to look up and see it and know that's what you're looking at.
Oh, that's so cool.
That's what I always say when I see it.
All right, folks. You are listening to York Universe, broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you are not already there, head over to yorku.ca/science/observatory to click over to OPV and join in the chat. Tonight, you are listening to myself, Judy Tomei, and Dr. Elena Hyde. We've just wrapped up our This Week in Astronomy and Space History. And we are going to do our little weekly reminder. It's a Valentine's Day coming up soon, and it happens to fall on a Wednesday
Oh my
this year.
gosh.
Oh my goodness. What a wonderful place to take your Valentine on a date, but the Allan I. Carswell Observatory.
That's right. It is, Julie. Thank you for saying so. It is a handy reminder that every Wednesday we are still doing in-person tours at the observatory. So this February 14th after sunset, you can come on out, and it's I have to say, it's pretty nice. There's the red lights are there to help with dark adapting your eyes, but seeing amazing things in space is a pretty fun way to spend any Wednesday. But I have to say, it's awfully nice that actually this year, February 14th, just falls right on the Wednesday for us.
I mean, I know of at least two marriages that started at the observatory. Just saying.
Well, you didn't hear it from me, folks.
Just saying.
But anecdotal evidence aside, it is still a very nice place to hang out. And fingers crossed for the clear weather, as you say. we have some hopes of additional clear skies in the next couple weeks. We'll see if those bear out, but it would be awfully nice if it could be clear on the Wednesdays. Obviously, we'll be doing a tour this week as well.
Great. And so people need to book tickets for that, yes?
Yes, on that same website that you've been telling people all episode. So don't worry if you missed it before. I'm sure you'll hear it again. That's the yorku.ca/science/observatory. The links are right there, so you can just click on it, get your free ticket, and come on out and have a good time every Wednesday.
Amazing. It's worth it.
Oh yeah. And I think as our other reminder was just if you are doing taxes, please remember that the donations are tax deductible. We definitely appreciate them. All right, so I guess we can get into some really juicy news items. It's
Let's
handy that
do it.
we've been talking about Hubble and teasing JWST, so I think we should talk about JWST.
I'm right there with you. Go for it.
All right. So everyone probably knows JWST stands for the James Webb Space Telescope. This particular telescope is out in orbit around L2 or in L2. It is currently following a little orbit going around in L2, which is on the other side of our moon. And if you haven't had the chance to really picture just how far away these things are. Since we're going to be talking about the JWST, I do want everyone to just close your eyes for a minute and imagine a basketball court. And you take the basketball and you put it on the little red line that I'm probably going to say wrong, but I'm pretty sure it's the free throw line. You put your basketball there and you get a tennis ball and you walk all the way down the court and you put the tennis ball all the way at the other side. Now, basketball and tennis ball at these other sides of the court, that's what you're looking at from like basically halfway across the court. That kind of size difference, that kind of distance, that's what we're looking at for the Earth and the moon. And so when we say WST is on the other side of the moon, you can get an idea. This is way out there, so it's not getting light pollution. It's protected from a lot of the noise and nonsense going on here in Earth, and it's also got a sun shield on it to help protect it from any additional heat. And this telescope, unlike the Hubble, this telescope looks in a kind of light that we can't see. So in infrared light, or as I like to call it, predator vision. This is the heat vision. It's the light that's emitted at these wavelengths outside of our human perception, but detectable by instruments and actually some animals as well. So why are we looking in infrared? Well, infrared is very, very good at bringing out certain kinds of details. It can bring out details in objects that are hot but maybe not so bright. It's very good at distant galaxies. It's good at looking for things that might be not maybe emitting very much light, like planets, actually, or in one case, exoplanets. So there have been a slew of amazing images brought out by JWST. And actually, just yesterday, I will say that Saturn has recently been imaged as well, and they don't look like what you might have traditionally seen as quote unquote pictures of Saturn or pictures of Neptune or pictures of Jupiter because they're not viewed in visible light. So it's literally not what you would see if you were there, but the features that are brought out by these are really really fun. So James Webb Space Telescope is good at finding things that are hidden by gas and dust. And exoplanets are often washed out by their neighbor stars, but in this case, and this is just 3 days ago, the James Webb Space Telescope was able to detect exoplanets orbiting dead stars, so stars that have already ended their lives. And this is I just think it's really cool. So obviously, if the star has ended its life, it can do so in multiple different ways. It will run out of fuel, which means it can't support itself anymore. It will start to collapse, and things get worse from there. So the outer layers have to go somewhere. You can get a planetary nebula or even a supernova. And what you end up with when the star is all done is you can end up with something called a white dwarf, a neutron star, a black hole. None of those emit very much light. White dwarfs mostly just because of their extremely small size. So planets around these stars that have already died is an interesting idea because uh, we've always wondered what's going to happen when our star finally runs out of fuel and expands out, perhaps out as far as the Earth and loses its gas and dust. What will happen to our planets? Would the planets even stay in orbit? Um, so these systems that they found are really, really interesting, and it's very different than our own solar system. But the JWST observation was actually it actually was able to find um, looking at these systems two different extrasolar planets orbiting two different white dwarfs or giant diamonds or dead stars, however you like to call them. So, white dwarfs are the highly compact core of what's left over. So, the planets that they found are also kind of crazy. They're solar system gas giant type planets. So, they're actually planets we think like Jupiter and Saturn. So, in a way, it's almost like we're getting a little peek into what our solar system might become one day. A very sad little white dwarf in the middle with a Jupiter and a Saturn out there, and not a lot of light going on. So, there's a bunch of really cool illustrations out there that you can look for. If you're looking at something about these exoplanets and they look really cool with lots of detail, please keep in mind those are definitely not the science images. Those are almost certainly artists' representations. Because these things are so, so, so faint, they really just show up as little black dots on the instruments of JWST. And this was the JWST instrument MIRI for those of you who are JWST fans. So there's a lot of fun things we can talk about this. Obviously, these are planets around another star, a white dwarf star, but still a star. So really cool. So one of the white dwarf stars, and they call white dwarf hosts. They basically have an exoplanet candidate that's about 11.5 times the distance from the Earth to the Sun. And the other one is more like 34.5 times the distance between the Earth and the Sun. So that's called 1 AU or 1 astronomical unit. The masses of the planets, which they can estimate by watching them go around their star, and a bit of math. So it looks like the masses are between 1 and 7 times that of Jupiter. So there's some pretty big error bars, but that's still Jupiter-ish. And it's a little bit of a hint at what could happen to the planets beyond Mars when our own sun dies. The gas giants Jupiter and Saturn will still be there, maybe even looking a little bit like these systems. So we've still got about 5 billion years, if anyone's counting. So don't worry. um, our sun will have fuel for about another 5 billion years. And only then afterwards will it swell up and become a red giant and puff up and expand out to probably Earth's orbit, maybe even Mars, actually, according to some models. But basically, Mercury, Venus, and Earth will not be places to be when that happens. So find an alternative in the next 5 billion years. And once that happens for any star, you get the remnants just left over. You're all out of fuel, nothing else to do. You get a planetary nebula, a white dwarf in the center, and in this case, we're seeing that the outer planets look to be pretty okay. They've definitely survived whatever's happened to the solar system. So, if you wind back the clock on these candidate planets, maybe they would have had orbital separations similar to Jupiter and Saturn. And we can, of course, do that with some modeling, because as you lose material from your star, you expect the planets to react to that as well. So we think that these planets are going to be really, really fun for um, you know for all kinds of studies about stellar evolution, and in particular what happens when suns like our own sun, do end their lives. And white dwarfs themselves are you know um, pretty interesting to study as well. They have very compact natures, and they actually have, in some cases, they can get what's called metals accumulating on them, and this is everything bigger than, or everything that's heavier than hydrogen and helium. Astronomers call metals, so apologies for that. But white dwarfs with this kinds of pollution means that probably they're being contaminated by possibly giant planets actually causing comets and asteroids to collect and collide onto the surface of the white dwarfs. So sort of throwing things into their host star. Um, and basically, um, any asteroids, they think what this would mean is that as the solar system dies, as the sun finally runs out of fuel, any asteroids or comets that survive that are out in your Oort cloud might find themselves suddenly pelted at the white dwarf in the center by large planets like Jupiter and Saturn, or in our case, actually Jupiter and Saturn. So, direct exoplanet detections are pretty rare as well. So this is a pretty cool one. I think honestly we're just now scratching the very tippy top of this story. So I'm looking forward to a lot more exoplanet news in the days to come.
So cool. Um,
Yeah,
yeah,
and as I say, don't forget we're talking about Saturn. Also, JWST also looked at Saturn. So
I just looked
we
at that image. Oh my goodness.
is so cool. And so JWST is not only out there finding exoplanets, it's also actually looking at our own solar system and showing us so much more detail than we'd be able to see in invisible light or with other methods. It really is as good as everyone says.
It is. So why don't I jump onto this JWST
Oh yes,
train,
absolutely.
do my thing, and then we can just talk about both of them together because it's all JWST.
Speaking of
Um,
being able to see awesome things.
yeah. So speaking of being able to see awesome things, speaking of not being able to see the thing we are in, I guess, directly. I don't know. It'll make sense once I say it. So, I mean, we live in the Milky Way. It is our galaxy. And in order to learn about it, astronomers have to get creative, especially when it comes to learning about its shape, because we're in the center of it. And one of the ways to do that is to not look at the Milky Way itself, but to look at other similar galaxies in the neighborhood. And there's this ongoing project called PHANGS, PHANGS, Physics at High Angular Resolution in Nearby Galaxies. They decided to leave the R out of there. That's fine. And it combines data from JWST, from Hubble Space Telescope, from the European Southern Observatory's Very Large Telescope's MUSE instrument, which is the multi-unit spectroscopic explorer, and the Atacama Millimeter Submillimeter Array in Chile, so ALMA or ALMA. And the goal of this study is to examine nearby galaxies with whirlpool shapes, same or similar to the Milky Way, in as many wavelengths as possible. So we've mentioned the Hubble's invisible. We've mentioned it's not invisible, it's in the visible wavelength. JWST is infrared. Then we're throwing in radio and we're throwing in ultraviolet as well. So you're combining all those data to better understand the interplay between small scale physics of gas and star formation and the larger scale galaxy structures and the evolution of galaxies. JWST images of 19 nearby galaxies were recently released and are, of course, stunning. And we have a good idea of the general spiral shape of the Milky Way, looking at the motion of stars, but the details are lacking. And we can't get a bird's eye view because that would mean sending a spacecraft thousands of light years away to do so, and we don't have the means to do that. JWST is invaluable in this project because it's got a huge mirror, 6.5 meters in diameter. So it has huge light collecting capacity. And as I mentioned, it's in infrared. So we're filling in more of that electromagnetic spectrum with data. But also, as Elena said, infrared penetrates cloud and dust. So it makes things that are obscure and visible wavelengths visible. The images show older stars are closer to the center of galaxies. Younger ones are in the spiral arms. There are huge bubbles of gas blown out by stars at the end of their lives. And another survey released last September that was also using JWST. Astronomers were surprised to find fully formed spiral galaxies only 3.7 billion years after the Big Bang, so approximately 13.7 billion years ago. And that was unexpected because spiral galaxies were thought to be like a later stage of galactic evolution. And so this shiny new instrument is making us rethink all sorts of things. It's so
Yeah.
cool.
Yeah, it really is. And it's as you say, it's it because it's able to do such an amazing job with the IR, it can get through the dust that would normally be obscuring our view in so many ways. And this study has some amazing astrophotography that's come out of it because when you combine all these different wavelengths, you get so much more detail about what's really going on in these systems. But it is worth noting if you're online looking at the JWST images, um, they're real, but they're absolutely not what you would see, right? Um, and the structures and stuff that they've been able to untangle and the questions that they're making us ask about, galaxies like, well, so how exactly does this work again? Because if you have the idea of hierarchical formation, which is galaxies building themselves up after time, then it takes some time for spiral galaxies to build. And like you say, they're, um, you know, well, 3.7 billion years, is that really enough time? Um, I don't know. Apparently it is somehow. So that's going to be fun.
Yes, this telescope is giving us so many new questions.
We
I
love
love it so
questions.
much. And not just giving us questions, like helping us answer them too.
Yeah, real proper mysteries. That's what we want.
Mm-hmm.
And also telescope time and clear skies,
Yes. I
as long
mean,
as we're asking for something.
astronomy can be a very frustrating science. You can't, all you can do is look,
Yes, but you might see something that no one has seen before.
right? You can't manipulate your subject. You can't, you know, mix things together and see what will happen. The time scales are all exceedingly long. Um, Want to know what will happen to our sun at the end of its life? You'll have to find something that's similar to it. Want to know what our galaxy looks like? You'll have to look at something that's similar to it. Want to know how far away something is? You're going to have to get creative in there too. Like,
Yeah, oh, the distance ladder. Don't get me started. We don't
oh
have time for that.
yes, we don't. But creativity is all
Yes.
I'm saying, and wonderful instruments. All
Yes,
right,
and I have
everyone.
to say it's very artistic. When they put these together, it is for science, but it really comes off as beautiful works of art as well.
Oh, gorgeous. All right, everyone. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde and myself, Julie Tomei. You can always connect with us on socials. Twitter/X, it's at York Universe, Instagram at York U Observatory, and on Facebook at Allan I Carswell Obs. Be sure to check out our website for all sorts of goodies, yorku.ca/science/observatory. Thank you for tuning in to York Universe. Clear skies and have a good night.
Good night, everyone.